Hello students, I'm going to continue section 5.3 on linear programming, and we're doing number 2, which is a fruit grower can use 2 types of fertilizer in his orange grove, brand A or brand B. Each bag of mix A contains 5 pounds of phosphoric acid, 2 pounds of chloride, 8 pounds of nitrogen. Each bag of mix B contains 5 pounds of phosphoric acid, 1 pound of chloride, 5 pounds of nitrogen. The grove needs at least, and I circled at least because that's an inequality right there, 2,500 pounds of phosphoric acid. At most is another inequality, 800 pounds of chloride. If the grower wants to maximize the amount of nitrogen, all right, so it's maximizing the number of nitrogen, added to the grove, how many bags of each mix should be used? How many bags of each mix should be used? And how much nitrogen will be added? Notice there's always this follow-up in these linear programming problems. Not only do we want to know how many bags of each mix, but we also want to know that amount of max or min at this point. What do we have to do? They want to maximize nitrogen. So it depends on the crop as to how much nitrogen you want. So we're going to go through this. A, define your variables. B, write the problem constraints. C, graph the feasible region. D, determine the corner points. E, write the objective function. F, evaluate the objective function at each of the corner points. And G, write your solution. All right, at least you have the directions. So let's see, how many bags of each mix? So I am going to say A, let X be the number of bags of brand A, and Y is the number of bags of brand B. Now I have this chart here. Remember, your column headings are this X and Y, I recommend, and then you've got phosphoric acid, chloride, and nitrogen. And then organize this material. Brand A has 5 phosphoric acid, 2 chloride, and 8, are we talking about pounds? Yes, of nitrogen. B has 5 pounds of phosphoric acid, 1 pound of chloride, and 5 pounds of nitrogen. I'm just organizing the material. Now the totals, it says at least 2,500 pounds of phosphoric acid, at most 800 pounds of chloride. These are restrictions on this crop, and we want to maximize the nitrogen. So that's your objective function. So let's take a look at our constraints. So from here, we can say 5x plus 5y. Well, at least means 2,500 or more, so that's greater than or equal to 2,500. 2x plus 1y at most means that we have to have less than or equal to 800. And we have x is greater than or equal to 0, y is greater than or equal to 0, because these bags have to be positive in value. Now we have our constraints, so part B is finished. Now part C, we're going to graph these. So I'm getting my purple pen out, I'm putting 0 in for x. If I put 0 in there, divide by 5, I get 500 for y. If I put 0 in for y, divide by 5, I get 500. So I'm going to graph this 0, 500, and 500, 0. I'm going to turn this a little to graph my line. Which side do I shade on? If I put 0, 0 in here, it is not greater than or equal to 0, so this is the side that I shade on. Now this shading, which side to shade on, it takes a while to figure that out. Some people get it right away. Most people don't. Most are like, which side do I shade on? I don't know. I've already had questions. Which side do I shade on? If you still have questions about shading, you can ask me. You can still get help at the Ackerman Learning Center. I'm going to be tutoring there tomorrow remotely. I'm not sure how that's going to work, but you can still get help at the Ackerman Learning Center. Go to the website and we'll figure out how we can give you help there. So now this one, if I let x equals 0, so I cover that up, x equals 0 wipes that out, and y gets 800. Now if I let y equals 0, divide by 2, I get the 400 here, so I've got 0, 800 right there. And 400, 0. I have to turn it a little in order to draw my line. So from here to here, here we go. There we go. You guys get your straight edges out. I cannot hold a camera in a straight edge. I have learned that. Now, which side of this? Well, 0, 0. If I put 0, 0 in here, is that less? Yes, it is. So I'm shading on this side of the red line. Ignore the purple. There we go. So what do I know? Where the purple and the red cross is in here. So here's only purple, only red, nothing. So I am talking about this region right in here. This is called the feasible region. Now let me tell you exactly what that means. The feasible region means that all of these ordered pairs in here, how many ordered pairs are in there? Infinitely many. That means that these ordered pairs satisfy this farmer's restrictions. So for example, 100, maybe, I don't know, 450 will satisfy all the constraints, meaning you can only have so much chloride, so much phosphoric acid. Every point in here, so 150 and this point and all these points, all these XYs, all these brand A, brand B, these bags of brand A and brand B, all of them will satisfy, but what we really want is a maximum. So I'll come back and show you how to find the maximum, the point that is what we're looking for in the problem.